Welcome back to Deep Space Dreams, where we drift through the deep past, one story at a time. Tonight, we're going on a slow, soothing journey into one of the most intriguing mysteries of our modern astronomical age, a journey into the question of whether the universe might be trying to tell us something through the most subtle of messengers, interstellar visitors that appear briefly in our skies before vanishing back into the eternal darkness from which they came. As always, I hope this video helps you drift off gently, or at least helps you put your worries into perspective by zooming out a few 100,000 years. Of course, there's a small risk that it might be too interesting and keep you awake, but if that happens, well, at least you'll have learned something fascinating along the way. Before we float off into the past together, I'd love it if you gave this video a like and maybe even subscribed if you haven't already. It really helps this sleepy little channel grow. I'd also love to know where you're watching from and what time it is for you right now. Let me know in the comments. It's always such a joy to see our sleepy history community scattered gently across the globe. Now, settle in. Get comfortable. You don't need to remember any of this. You don't need to take notes or stay alert. Just let the words wash over you like whispers on the wind. And as we begin this gentle voyage into the vast unknown, remember this video is for educational and relaxation purposes only, and is not intended as medical advice. Ready? Let's begin. Perhaps you've never considered just how profoundly empty space truly is. We live our lives surrounded by matter, by air and earth and water, by the constant presence of things we can touch and see and feel. But out there, in the vast expanses between the stars, emptiness reigns supreme. If you were to take a cubic meter of space from anywhere on Earth, even from what we might consider the emptiest desert or the highest mountain peak, you would find it teeming with molecules, with billions upon billions of atoms dancing their eternal dance. But take that same cubic meter from the space between stars, and you might find perhaps a single atom, maybe two. The void between stars is so empty that it defies human comprehension. It is a vacuum more perfect than anything we could ever create in our most sophisticated laboratories. And yet, through this almost perfect emptiness, things do travel, objects do move, silent voyagers cross the unimaginable distances between star systems, journeying for millions, perhaps billions of years through the cosmic dark. Most of these travelers we will never see. They pass by in the night, invisible and unknowable, their paths taking them nowhere near our small corner of the universe. But occasionally, very occasionally, one of these cosmic wanderers finds its way into our neighborhood, and when it does, when we're fortunate enough to spot it with our telescopes and track its path through our solar system, we're given a precious opportunity to study something that comes from somewhere else entirely. Something that was born under an alien sun, shaped by forces we can only imagine, and sent on a journey that would eventually bring it to our doorstep. The idea of interstellar visitors is not new. For decades, astronomers have known that such objects must exist. After all, when solar systems form, not everything stays neatly in place. Planets migrate, comets get flung outward, asteroids collide and scatter. In the chaotic early days of any star system, countless objects are ejected into interstellar space, doomed to wander the darkness forever. Our own solar system has certainly contributed its share to this cosmic diaspora. We've sent untold numbers of comets and asteroids spinning off into the void, never to return. And if we've done this, then so has every other star system in the galaxy. The space between stars should be populated, however sparsely, with these orphaned objects, these cosmic refugees from distant suns. But knowing something exists in theory, and actually seeing it are two very different things. For most of human history, we've had to content ourselves with the knowledge that interstellar visitors must be out there, somewhere, even if we could never hope to see them. The distances involved are simply too vast, the objects too small and dark, and our instruments, for all their sophistication, too limited. It would be like trying to spot a grain of sand floating in the middle of the Pacific Ocean at night. Theoretically possible, perhaps, but practically impossible. And then, in October of 2017, everything changed. For the first time in recorded history, we spotted an object that we could definitively say had come from beyond our solar system. It was given the name Oumuamua, a Hawaiian word meaning scout, or messenger from afar arriving first. The name was fitting, for this object was indeed a messenger, though what message it carried, if any, remains a mystery to this day. Oumuamua was unlike anything we had ever seen before. It was elongated, perhaps 10 times longer than it was wide, tumbling through space like a cosmic cigar. It showed no signs of outgassing, no comet-like tail, despite passing close to the sun. And strangest of all, it appeared to accelerate as it left our solar system, pushed by some force that we still don't fully understand. The discovery of Oumuamua sent ripples through the scientific community. Here, at last, was proof that interstellar visitors could indeed be detected and studied. Here was an object that had travelled from another star system, carrying with it information about its place of origin, if only we could decode it. But Oumuamua was also frustrating. We spotted it late, only after it had already made its closest approach to the Sun and was heading back out into interstellar space. We had just a few weeks to study it before it faded from view, and many of our observations raised more questions than they answered. What was it made of? Why was it so elongated? What caused its mysterious acceleration? We may never know the answers to these questions, for Oumuamua is gone now, continuing its eternal journey through the darkness, carrying its secrets with it. But Oumuamua taught us something important. It taught us that we could find these visitors if we looked carefully enough. It taught us what to look for, how to distinguish an interstellar interloper from the countless asteroids and comets that belong to our own solar system. And perhaps most importantly, it taught us to keep watching, to keep our telescopes trained on the darkness, waiting for the next visitor to arrive. We didn't have to wait long. Less than 2 years after Oumuamua's departure, in August of 2019, another interstellar visitor was discovered. This one was different from the first, showing clear signs of cometary activity, sprouting a tail as it approached the Sun. It was given the designation 2I/Borisov, named after the amateur astronomer who first spotted it. Borisov was, in many ways, less mysterious than Oumuamua. It behaved like a comet, looked like a comet, and apart from its interstellar origin, seemed relatively unremarkable. But in its own way, Borisov was just as important as Oumuamua. It showed us that interstellar visitors might be more common than we had thought. If we could spot 2 in just 2 years, how many more might be out there, waiting to be discovered? And then, in 2020, something curious happened. Another object was discovered that appeared to have an interstellar origin. It was given the designation 3/ATLAS, the third confirmed interstellar object to visit our solar system. But this visitor would prove to be perhaps the strangest of all, not because of its shape or its composition, but because of what happened to it as it approached the Sun. Because 3I/ATLAS, this messenger from the stars, began to fall apart, and the way it fell apart, the timing of its disintegration, has led some to wonder whether we witnessed not just the death of a comet, but something else entirely, something that might have been intended. Consider for a moment the challenge of sending a message across interstellar space. Radio signals weaken with distance, becoming lost in the cosmic background noise. Physical probes would take millions of years to reach even the nearest stars. But what if there was another way? What if you could send a message that was designed not to survive its journey intact, but to reveal itself only upon arrival? What if the message wasn't in the medium, but in its destruction? This might sound like science fiction, and perhaps it is. The scientific consensus is that 3I/ATLAS was simply a comet, albeit one from another star system that couldn't withstand the heat of our Sun. But as we drift together through this cosmic mystery tonight, we're going to explore all the possibilities, both mundane and extraordinary. We're going to consider what we know, what we think we know, and what we might be missing entirely. Because sometimes, in the quiet depths of space, the most interesting questions are the ones we haven't thought to ask yet. The story of 3/ATLAS begins not with the object itself, but with the system that discovered it. A TLAS stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to scan the sky for potentially hazardous asteroids. Every clear night, these robotic sentinels sweep across the heavens, taking multiple images of the same patches of sky, looking for anything that moves against the fixed backdrop of stars. It's patient, methodical work, mostly automated, with computers analysing the vast majority of the data. But occasionally, something unusual appears, something that doesn't fit the normal patterns, something that requires human attention. On the night of August 28, 2020, the Atlas telescope in South Africa detected a faint point of light that was moving in an unusual way. At first, it seemed like just another comet, one of the many that are discovered each year. But as astronomers calculated its orbit, they realized that this object was special. Its trajectory indicated that it had come from outside our solar system, approaching from the direction of the constellation Columba, the Dove. Like Oumuamua and Borisov before it, this object was an interstellar visitor, a piece of another star system that had somehow found its way to ours. The discovery of a third interstellar object in just 3 years was exciting enough, but what happened next made 3I/ATLAS truly remarkable. As it approached the Sun, astronomers around the world turned their telescopes toward it, eager to study this latest visitor from the stars. They expected to see it brighten as it got closer to the Sun, perhaps developing a more prominent tail as solar radiation heated its surface and caused frozen gases to sublimate. This is what comets do. This is what Borisov had done. But 3I/ATLAS had other plans. Instead of brightening, the object began to fade. Instead of remaining a single coherent body, it began to fragment. Through telescopes, astronomers watched as 3I/ATLAS broke apart into smaller and smaller pieces, a slow-motion disintegration playing out across millions of miles. By the time it made its closest approach to the Sun in May 2021, there was little left of the original object. What had arrived as a single body had become a cloud of debris, spreading out along its orbital path like cosmic breadcrumbs. The fragmentation of comets is not unusual. In fact, it happens fairly regularly. Comets are, after all, rather fragile things. They're often described as dirty snowballs, loosely bound collections of ice, dust, and rock that can be torn apart by the Sun's gravity or heat. We've observed many comets breaking up as they approach the Sun, sometimes spectacularly. But there was something about the way 3I/ATLAS fragmented that gave some observers pause. The timing seemed almost deliberate. The object had survived its long journey through interstellar space, had entered our solar system intact, and then, just as it reached the point where it would be most visible to us, it fell apart. Was this simply coincidence? Most likely, yes. The scientific explanation is straightforward enough. 3I/ATLAS was probably a particularly fragile comet, perhaps one that had been weakened by its eons-long journey through space. The stress of approaching our Sun, with its heat and gravitational forces, was simply too much for it to bear. It broke apart as many comets do, and that was that. Case closed. Mystery solved. But what if we're missing something? What if our assumption that this was a natural object behaving naturally is preventing us from seeing a different possibility? Throughout history, some of humanity's greatest discoveries have come from questioning what seems obvious, from looking at familiar phenomena with fresh eyes. And when we look at 3I/ATLAS with fresh eyes, some intriguing questions emerge. Consider the timing of the fragmentation. The object began breaking apart just as it entered the inner solar system, the region where our telescopes could best observe it. If you wanted to ensure that a message or signal was noticed by any civilization monitoring the skies, wouldn't you want it to activate or reveal itself in just this region? Too far out, and it might be missed entirely. Too close to the sun, and it might be lost in the glare. But right there, in that sweet spot where Earth-based telescopes could track it clearly, that's where 3I/ATLAS began its performance. Consider too the nature of the fragmentation. When comets break apart, they typically do so violently, in sudden events caused by explosive outgassing or tidal forces. But 3I/ATLAS seemed to fragment more gently, more gradually. It was less like an explosion and more like a dissolution, as if the object was designed to come apart in just this way. Imagine, for a moment, a dandelion seed head. When the wind blows, it doesn't explode. It releases its seeds gently, each one drifting away to find its own path. What if 3I/ATLAS was something similar? What if its fragmentation wasn't a death, but a dispersal? This brings us to one of the most fascinating possibilities about 3I/ATLAS, one that we'll explore more deeply as our journey continues tonight. What if this object was not a natural comet at all, but some form of artificial probe? Not a solid metallic spacecraft like we might imagine, but something more subtle, more elegant. Perhaps a probe designed to mimic a natural object, to avoid detection or alarm. Perhaps a probe made primarily of ice and organic compounds, materials that would be indistinguishable from a natural comet until you looked very, very closely. The idea of disguising an artificial probe as a natural object is not as far-fetched as it might seem. In fact, it's something we've considered for our own future space exploration. Some scientists have proposed that the best way to study other star systems might be to send probes that look and behave like natural objects. These lurker probes could drift through a system unnoticed, observing and recording without alerting any potential inhabitants to their presence. And if we've thought of this, who's to say that other civilizations haven't thought of it too? But why would such a probe fragment? Here, we enter the realm of pure speculation, but it's speculation worth considering on this quiet night as we contemplate the cosmos. Perhaps the fragmentation was intentional, a way of dispersing sensors or beacons throughout our solar system. Each fragment could be a separate component, now free to follow its own trajectory, to explore different regions of our cosmic neighborhood. Or perhaps the fragmentation was a form of communication itself, a signal designed to catch our attention, to make us look more closely. There's another possibility too, one that's both more subtle and more profound. What if the probe was designed to release something at just the right moment? Not fragments of itself, but something else. Information, encoded in molecules or exotic particles, microscopic devices too small for our telescopes to see. Or even just patterns, mathematical or physical patterns, embedded in the way the object broke apart, waiting for a sufficiently advanced civilization to decode them. The universe, after all, is full of patterns. From the spiral of galaxies to the structure of atoms, patterns repeat across scales and distances. What if 3I/ATLAS carried a pattern with it, one that was revealed only in its destruction? As we consider these possibilities, it's important to remember that we're not making claims or assertions. We're simply exploring ideas, letting our minds wander through the realm of what might be possible. The truth is, we don't know what 3I/ATLAS was. We probably never will. It's gone now, its fragments dispersed, continuing their journey through our solar system and eventually back out into interstellar space. Whatever secrets it might have held, whatever message it might have carried, they're lost to us now. Or are they? One of the most intriguing aspects of 3I/ATLAS is that its fragments might still be out there, somewhere in our solar system. When the object broke apart, not all of the pieces would have followed exactly the same path. Some might have been slowed more than others. Some might have been deflected by the gravitational pull of planets. It's possible, even likely, that some fragments of 3I/ATLAS are still drifting through our cosmic neighborhood, too small and faint for us to detect with current technology, but still there, still carrying whatever they've always carried. This raises a fascinating question. If 3I/ATLAS was indeed some form of probe or message, could its fragments still be active? Could they be out there right now, quietly observing, recording, perhaps even transmitting? The idea might seem fantastic, but consider how we design our own space probes. The Voyager spacecraft, launched in the 1970s, are still operational after more than 4 decades in space. They're still transmitting data back to Earth, even as they exit our solar system and enter interstellar space. If we can build probes that last for decades, who's to say that a more advanced civilization couldn't build probes that last for millennia, or longer? The fragments of 3I/ATLAS, if they're out there, would be incredibly difficult to find. They would be small, dark, and moving through a vast volume of space. It would be like searching for a handful of pebbles scattered across a continent. But difficult doesn't mean impossible. As our detection technology improves, as we launch more sophisticated space telescopes and develop better search algorithms, we might one day be able to track down these fragments. And if we do, if we can capture and study even one piece of 3I/ATLAS, we might finally have answers to some of our questions. But perhaps the fragments aren't meant to be found. Perhaps they're meant to remain hidden, silent observers in our solar system watching and waiting. This might sound ominous, but consider it from a different perspective. If you were an advanced civilization trying to study primitive worlds without interfering with them, wouldn't you want your probes to be as unobtrusive as possible? Wouldn't you design them to observe without being observed, to gather information without affecting the subjects of your study? This concept, sometimes called the zoo hypothesis, suggests that Earth might be under observation by advanced civilizations who have chosen not to make contact with us, at least not directly. Like animals in a nature preserve, we're being watched and studied, but from a distance, without interference. The observers remain hidden, following something like Star Trek's Prime Directive, a policy of non-interference with developing civilizations. If this hypothesis has any truth to it, then objects like 3I/ATLAS might be part of the observation system, cosmic cameras or sensors drifting through our solar system, recording our progress or lack thereof. The idea that we're being watched might be unsettling to some, but there's another way to look at it. If advanced civilizations are indeed observing us, it means we're not alone. It means the universe has produced intelligence other than our own. It means that it's possible for civilizations to survive long enough to develop interstellar technology. In a universe that often seems hostile to life, where extinction events and cosmic catastrophes are commonplace, the existence of advanced observers would be profoundly reassuring. It would mean that intelligence can persist, can thrive, can spread among the stars. As we contemplate these possibilities, drifting deeper into the mystery of 3I/ATLAS, it's worth remembering how young we are as a spacefaring species. We've only been able to detect interstellar objects for a few years. We've only been listening for signals from other civilizations for a few decades. In cosmic terms, we've barely opened our eyes. We're like children who have just learned to look up at the night sky, only beginning to comprehend the vastness and complexity of what's out there. And like children, we're full of questions, full of wonder, full of possibilities. The discovery of 3I/ATLAS, like the discoveries of Oumuamua and Borisov before it, reminds us that our solar system is not isolated. We're part of a galactic community, even if we don't yet know who our neighbors are. Objects from other star systems pass through our neighborhood. Some we see, most we don't. Each one is a messenger, carrying information about its origin, its journey, and perhaps, just perhaps, its purpose. Whether that purpose is natural or artificial, random or deliberate, remains to be seen. As you lie there in the darkness, perhaps beginning to feel the gentle pull of sleep, consider the cosmic dance that's happening all around us. Right now, at this very moment, there are probably dozens, maybe hundreds of interstellar objects passing through our solar system. Most are too small or too distant for us to detect. They drift silently through the darkness, unseen and unknown, carrying their secrets with them. But they're there, these cosmic wanderers, these messengers from other suns. They've been passing through our neighborhood for billions of years, long before Earth existed, and they'll continue passing through long after we're gone. Some of these objects might be natural, simple chunks of rock or ice ejected from distant star systems. Others might be comets like 3I/ATLAS, fragile assemblies of frozen gases and dust that break apart when they get too close to our sun. But perhaps, just perhaps, some of them are something more. Perhaps some of them are artifacts, relics of civilizations that rose and fell before our sun was even born. Perhaps some of them are active probes, still functioning after eons in space, still carrying out their missions of observation or communication. The possibility that 3I/ATLAS might have been artificial, might have been a signal or a probe, raises profound questions about the nature of communication across cosmic distances. If you wanted to send a message to another star system, how would you do it? Radio signals fade with distance. Even our most powerful transmissions become indistinguishable from background noise after just a few light years. Sending a physical probe would take millions of years, and there's no guarantee it would ever be found. But what if you could send something that would announce itself, that would make itself known in a way that couldn't be ignored? The fragmentation of 3I/ATLAS might have been just such an announcement. Not a subtle signal hidden in radio waves, but a visible, dramatic event that any civilization with telescopes would notice. The object enters a solar system intact, approaches the central star, and then breaks apart in full view of any observers. It's like setting off a flare in the darkness, a bright, unmistakable signal that says, "Look here, pay attention, this is important." But what would be the message? If 3I/ATLAS was indeed a signal, what was it trying to tell us? Here we can only speculate, but the speculation itself is illuminating. Perhaps the message was simply, "You are not alone." Perhaps it was a test to see if we're advanced enough to recognize an artificial signal when we see one. Perhaps it was an invitation, a breadcrumb leading us to look more closely at interstellar visitors, to develop better detection methods, to prepare ourselves for future contact. Or perhaps there was no specific message at all. Perhaps the medium was the message, as Marshall McLuhan might say. The mere fact of an artificial object from another star system would be message enough. It would tell us that intelligence exists elsewhere in the universe. It would tell us that interstellar travel, or at least interstellar probe deployment, is possible. It would tell us that someone, somewhere, somewhen, thought it was worth sending something our way. As we continue our journey through this cosmic mystery, we find ourselves at an interesting crossroads. We've explored the idea that 3I/ATLAS might have been more than just a comet, might have been some form of signal or probe. We've considered the implications of its fragmentation, the possibility that it was designed to break apart in just the way it did. We've wondered about its fragments, possibly still drifting through our solar system, carrying unknown cargo or serving unknown purposes. But now we must turn our attention to what we actually know, to the scientific observations and measurements that form the foundation of our understanding. The study of 3I/ATLAS was challenging from the start. Unlike Oumuamua, which remained a single object throughout our observations, 3I/Atlas began fragmenting while we were still trying to understand what it was. This made it difficult to determine its original size, composition, and structure. It's like trying to reconstruct a vase from scattered shards, except the shards are millions of miles away and moving at tremendous speeds. But despite these challenges, astronomers were able to gather valuable data about our mysterious visitor. spectroscopic analysis of the light reflected by 3I/ATLAS revealed that it was rich in carbon compounds, similar to many comets from our own solar system. This was both reassuring and puzzling. Reassuring because it suggested that the basic chemistry of comets might be similar across different star systems. Puzzling because if 3I/ATLAS was so similar to our own comets, why did it behave so strangely? Why did it fragment in the particular way it did? The trajectory of 3I/ATLAS also provided clues about its origin. By tracing its path backward, astronomers attempted to determine which star system it might have come from. But here they encountered a problem. The object had been travelling through interstellar space for so long that its path had been affected by the gravitational pull of many stars. It was like trying to determine where a leaf had fallen from after it had been blown by winds for days. The best astronomers could say was that 3I/ATLAS came from the general direction of the constellation Columba, but its specific point of origin remained a mystery. The speed of 3I/ATLAS was another interesting data point. It entered our solar system at about 26 kilometers per second relative to the Sun. This is fast, but not unusually so for an interstellar object. It's about the speed you'd expect for something that had been ejected from another star system and had been drifting through space for millions of years. But speed can be deceiving. If 3I/ATLAS was indeed artificial, its creators might have deliberately chosen a speed that would seem natural, that wouldn't raise immediate suspicions. One of the most intriguing observations about 3I/ATLAS was the way it fragmented. When comets break apart, they usually do so along planes of weakness, like a piece of wood splitting along its grain. But 3I/ATLAS seemed to fragment more uniformly, breaking into pieces of roughly similar size. This could be explained by the object having a very homogeneous structure, unlike the layered structure we see in many comets, but it could also be explained by the object being designed to fragment in just this way, each piece serving a specific purpose. As we delve deeper into the scientific observations of 3I/ATLAS, we begin to see a pattern emerging. Every piece of data can be interpreted in two ways. There's always a natural explanation, a way to understand the observations within our current scientific framework. But there's also always room for doubt, always a crack through which alternative explanations can slip. This ambiguity is both frustrating and fascinating. It keeps the mystery alive, keeps us wondering, keeps us looking up at the stars and asking, what if? The timing of 3I/ATLAS's discovery is also worth considering. We found it in 2020, just 3 years after discovering Oumuamua, the first confirmed interstellar object. This might seem like a remarkable coincidence, two rare events happening so close together, but perhaps it's not a coincidence at all. Perhaps interstellar objects have been passing through our solar system all along, and we've only recently developed the technology to detect them. Or perhaps something has changed, something that's causing more interstellar objects to visit our neighborhood. One possibility is that we're passing through a region of space that's particularly rich in interstellar debris. Our solar system orbits the center of the Milky Way galaxy, completing one revolution every 230 million years or so. As we travel along this galactic orbit, we pass through different regions of space, some denser with stars and debris than others. Perhaps we've recently entered a region where interstellar objects are more common, a cosmic highway where the traffic from other star systems is particularly heavy. Another possibility, more speculative but worth considering, is that the increase in interstellar visitors is not random. Perhaps something has prompted other civilizations to send probes our way. Perhaps our radio emissions, which have been spreading outward from Earth for about a century now, have finally reached someone who decided to investigate. Perhaps our nuclear tests, which would be visible as brief flashes of gamma rays to anyone with the right instruments, caught someone's attention. Or perhaps it's something else entirely, something we haven't even considered. As we ponder these possibilities, Drifting ever deeper into the cosmic mystery, it's important to maintain a balance between skepticism and openness. We should be skeptical of extraordinary claims that lack extraordinary evidence. We should apply Occam's razor, favouring simple explanations over complex ones. But we should also remain open to possibilities that challenge our assumptions, that push the boundaries of what we think we know. The history of science is full of discoveries that seemed impossible until they weren't, full of phenomena that defied explanation until someone found the right way to look at them. The fragmentation of 3I/ATLAS presents us with just such a phenomenon. On one hand, it's easily explained as the natural breakup of a fragile comet. On the other hand, the specific details of how and when it fragmented raise questions that don't have easy answers. Why did it begin fragmenting just as it entered the region where we could best observe it? Why did it break into pieces of similar size? Why did some fragments seem to accelerate away from the main body in ways that are difficult to explain without gassing alone? These questions lead us to consider more exotic possibilities. What if 3I/ATLAS was made of exotic matter, something that behaves differently from the ordinary matter we're familiar with? What if it contained technology so advanced that we can't recognize it as technology? Arthur C. Clarke's famous third law states that any sufficiently advanced technology is indistinguishable from magic. Perhaps we're looking at something so far beyond our current understanding that we can't even recognize it for what it is. Consider for a moment how our own technology might appear to someone from a few centuries ago. A smartphone would seem like magic, a thin piece of glass that can show moving pictures, play music and allow communication with people on the other side of the world. They wouldn't be able to understand how it works, wouldn't even have the conceptual framework to begin understanding it. Now extrapolate that into the future. What might technology look like in 1,000 years? 1,000,000 years? 1,000,000,000 years? It might be so integrated with what we consider natural processes that we couldn't distinguish it from nature itself. This brings us to an interesting thought experiment. If an advanced civilization wanted to send us a message or a probe, how would they do it? They might reasonably assume that we would be suspicious of anything that looked obviously artificial. A metallic spacecraft approaching our solar system would trigger alarm and possibly fear. But a comet? Comets are natural, familiar, non-threatening. We've been observing them for thousands of years. They're part of the natural order of things. If you wanted to observe a primitive civilization without alarming them, disguising your probe as a comet would be a clever strategy. But why go to all that trouble? Why not simply announce themselves, make contact directly? Here we enter the realm of exosociology, the study of hypothetical alien societies. Perhaps direct contact is forbidden by some galactic treaty or ethical code. Perhaps they're studying us to determine if we're ready for contact. Perhaps they're not interested in us specifically, but are conducting a general survey of life in the galaxy. Or perhaps they're so different from us that direct communication is impossible, and these subtle signals are the best they can do. As we contemplate these possibilities, the fragments of 3I/ATLAS continue their journey through our solar system. Some are probably already on their way back to interstellar space, following hyperbolic orbits that will take them away from our sun forever. Others might have been captured into elliptical orbits, destined to return to the inner solar system in decades or centuries. And some might have impacted planets or moons, their material now part of our solar system forever. If any of these fragments landed on Earth, we would probably never know. They would be too small to survive passage through our atmosphere intact. They would burn up, their material dispersing in the upper atmosphere, drifting down as microscopic particles indistinguishable from ordinary cosmic dust. But what if those particles carried something with them? Information encoded at the molecular level? Dormant microorganisms from another world? The building blocks for something we can't even imagine. These ideas might sound like science fiction, and perhaps they are. But science fiction has a curious way of becoming science fact. Jules Verne wrote about submarines and space travel long before they became reality. Arthur C. Clarke predicted communication satellites decades before they were launched. Perhaps someone, somewhere is writing about interstellar messengers that fragment upon arrival, and perhaps, just perhaps, they're writing about something that has already happened. As the first part of our journey draws to a close, we find ourselves surrounded by questions rather than answers. Was 3I/ATLAS simply a comet that happened to break apart at an interesting time? Or was it something more, something designed to catch our attention, to make us think, to make us wonder? We may never know for certain. The object is gone, its fragments scattered, its secrets dispersed across millions of miles of space. But the questions it raised remain, floating in our minds like the fragments themselves float in space. The universe has a way of presenting us with mysteries just when we think we understand things. Just when we develop the technology to detect interstellar objects, they start appearing with properties that challenge our expectations. Just when we think we understand comets, one behaves in ways we didn't predict. It's as if the cosmos is reminding us to stay humble, to keep questioning, to never assume we have all the answers. And perhaps that's the real message of 3I/ATLAS. Not a specific communication from an alien civilization, but a reminder from the universe itself that there's always more to discover, always more to learn, always more to wonder about. The fragments of 3I/ATLAS continue their silent journey through our solar system as we turn our attention to understanding what this visitor might have truly been. When we look at the cosmos, we often see what we expect to see, what our theories and models tell us should be there. But sometimes, just sometimes, the universe presents us with something that doesn't quite fit, something that makes us pause and reconsider our assumptions. 3I/ATLAS was one of those somethings, a cosmic puzzle piece that seems to belong to a picture we haven't yet assembled. To understand what 3I/ATLAS might have been, we must first understand what comets are, these ancient wanderers that have captivated humanity since we first looked up at the night sky. Comets are time capsules, preserved remnants from the birth of star systems. When a star forms, it doesn't use all the material in its stellar nursery. Some of that material, the ice and dust and small rocks, gets left behind in the cold outer reaches of the newly formed system. There it remains, frozen and unchanging, for billions of years. These are the comets, waiting in the darkness for something to disturb them, to send them falling toward their parent star where they briefly bloom into magnificent displays before returning to the cold or sometimes meeting their end. In our own solar system, we have two main reservoirs of comets. There's the Kuiper Belt, a ring of icy bodies beyond Neptune's orbit, and the Oort cloud, a vast spherical shell of comets that extends nearly halfway to the nearest star. These regions contain trillions of comets, most of which will never venture into the inner solar system where we could see them. They'll spend eternity in the darkness, frozen and forgotten. But occasionally a gravitational nudge from a passing star or a giant planet sends one of these comets inward, and we get to witness its transformation from a dark, frozen nucleus to a glowing spectacle with a tail that can stretch for millions of miles. The composition of comets tells us about the conditions that existed when they formed. They're mostly water ice, but not just water ice. They contain frozen carbon dioxide, methane, ammonia, and a variety of organic compounds. Some scientists call them dirty snowballs, but this doesn't do justice to their complexity. Comets contain amino acids, the building blocks of proteins. They contain complex carbon molecules that could serve as precursors to life. Some scientists believe that comets might have delivered much of Earth's water and organic material, seeding our planet with the ingredients necessary for life to emerge. When a comet approaches the Sun, it undergoes a remarkable transformation. The Sun's heat causes the frozen gases to sublimate, turning directly from solid to gas. This creates a cloud of gas and dust around the nucleus called a coma, which can be larger than Jupiter. The solar wind and radiation pressure then push this material away from the Sun, creating the comet's characteristic tail. Actually, comets often have two tails, one made of dust that follows the comet's orbital path, and one made of ionized gas that points directly away from the Sun. It's a beautiful dynamic process, a cosmic dance of ice and fire, matter and energy. But 3I/ATLAS didn't quite follow this familiar script. Yes, it developed a coma as it approached the Sun. Yes, it showed signs of outgassing. But then it did something unexpected. Instead of simply sublimating its volatile materials while maintaining its structural integrity, it began to fragment. And not in the violent, explosive way that some comets fragment, but in a more gradual, almost methodical manner. It was as if the object was dismantling itself, piece by piece, following some internal blueprint we couldn't see. The fragmentation of comets is not unprecedented. We've observed many comets breaking apart over the years. Comet Shoemaker-Levy 9 famously fragmented into multiple pieces before crashing into Jupiter in 1994, giving us a front-row seat to a cosmic collision. Comet Linear broke apart in 2000 as it passed close to the Sun. Comet Eason disintegrated in 2013 during its close solar approach. Each of these events taught us something about cometary structure and composition, but each of them also followed patterns we could understand and explain within our existing framework of cometary physics. The fragmentation of 3I/ATLAS was different in subtle but important ways. First, there was the timing. The object began fragmenting when it was still relatively far from the Sun, farther than where we typically see comets experiencing the stresses that lead to breakup. The solar heating at that distance shouldn't have been intense enough to cause such dramatic structural failure, especially for an object that had survived the much harsher environment of interstellar space for potentially millions of years. Think about what interstellar space is like. It's cold, colder than anywhere in our solar system except perhaps the permanently shadowed craters at the poles of some moons. The temperature out there approaches absolute zero, just a few degrees above the coldest possible temperature in the universe. But it's not just cold, it's also bombarded by cosmic rays, high-energy particles that can gradually erode and alter materials over time. Any object that can survive millions of years in this environment should be incredibly robust, hardened by its long exposure to the harsh realities of interstellar space. Yet 3I/ATLAS, this veteran of interstellar space, began falling apart as soon as it entered our relatively benign inner solar system. It's like a mountaineer who successfully climbs Everest, only to collapse while walking through a meadow. Something doesn't quite add up. Either the object was much more fragile than we would expect, or something else was happening, something our current models don't account for. One possibility is that 3I/ATLAS was composed of unusual materials or had an unusual structure. Perhaps it was more porous than typical comets, filled with voids and caverns that made it structurally weak. Perhaps it was made of a type of ice that's particularly susceptible to thermal stress. We know that different types of ice can form under different conditions. There's the ordinary ice we're familiar with, but there are also exotic forms of ice that exist only under extreme pressures or temperatures. Perhaps interstellar space creates conditions that produce ice, with properties we haven't yet encountered or fully understood. Another possibility is that 3I/ATLAS had been damaged during its interstellar journey. Perhaps it had collided with something, a grain of dust travelling at high speed that created internal fractures. In interstellar space, even a tiny particle could carry enormous energy if the relative velocity was high enough. These impacts might have created a network of cracks throughout the object, invisible from the outside but weakening the entire structure. When the object finally encountered the Sun's heat, these pre-existing fractures could have propagated, causing the observed fragmentation. But there's another explanation we must consider, one that takes us beyond conventional cometary science. What if 3I/ATLAS ATLAS was designed to fragment? What if what we witnessed was not a failure but a function? This brings us back to the possibility that 3I/A TLAS was artificial, or at least artificially modified. It's a possibility that most scientists are reluctant to consider, and for good reason. Extraordinary claims require extraordinary evidence, and we don't have that evidence. But the absence of evidence is not evidence of absence, and sometimes it's worth exploring unconventional ideas, if only to better understand why the conventional explanations are probably correct. If 3I/ATLAS was some form of artificial probe, its fragmentation could have served several purposes. It could have been a way of dispersing sensors or beacons throughout our solar system. Each fragment could be a separate instrument, now free to explore different regions or monitor different phenomena. It's not unlike how we sometimes deploy multiple small satellites instead of one large one, distributing our observations across space and time. The fragmentation could also have been a form of communication. In the same way that we encode information in radio waves or laser pulses, information could potentially be encoded in the pattern of fragmentation. The size of the fragments, their velocities, their trajectories, all of these could carry meaning to someone who knew how to read them. It would be a subtle form of communication, one that would look natural to casual observers but might reveal patterns to those who looked closely enough. There's even the possibility that the fragmentation was a disposal mechanism. If the probe had completed its mission, if it had gathered whatever data it was sent to collect, fragmentation might have been a way of ensuring that the technology couldn't be captured and studied. By breaking into small pieces that would quickly disperse, the probe would effectively destroy itself while appearing to undergo a natural process. It's the cosmic equivalent of a self-destruct mechanism, but one that leaves no obvious evidence of its artificial nature. As we contemplate these possibilities, it's worth remembering that we're not the first to wonder about artificial interstellar visitors. When Oumuamua was discovered, its unusual properties led some scientists to seriously consider the possibility that it might be artificial. Its elongated shape was unlike anything we had seen before. Its lack of cometary activity despite passing close to the Sun was puzzling. And most mysteriously, it appeared to accelerate as it left our solar system, pushed by a force that couldn't be fully explained by outgassing or other known phenomena. The debate about Oumuamua continues to this day. Most scientists believe it was a natural object, perhaps a fragment of a planet or an unusual type of comet. But a few researchers, most notably Avi Loeb from Harvard University, have argued that we shouldn't dismiss the possibility that it was artificial. Loeb has suggested that Oumuamua might have been a light sail, a thin sheet of material designed to be pushed by stellar radiation. It's a controversial idea, one that most of the scientific community rejects, but it's an idea that refuses to go away entirely. The discovery of Oumuamua changed how we think about interstellar visitors. Before Oumuamua, we expected that the first interstellar object we detected would be a comet, something that would announce itself with a bright coma and tail as it approached the Sun. Instead, we got something ambiguous, something that didn't fit neatly into our categories. It forced us to confront the limitations of our assumptions and the possibility that the universe might be stranger than we imagined. When Borisov was discovered 2 years later, it seemed to restore some normalcy. Here was an interstellar visitor that behaved exactly like a comet should behave. It developed a coma and tail. Its spectrum showed the presence of familiar molecules like water and cyanogen. Apart from its interstellar origin, it was remarkably unremarkable. Some scientists breathed a sigh of relief. Perhaps Oumuamua was just a fluke, an unusual but ultimately natural object. Perhaps most interstellar visitors would be like Borisov, familiar and comprehensible. But then came 3I/ATLAS, and with it, new questions. Why did it fragment when Borisov didn't? Why did it break apart in such a systematic way? Was there something special about this object? Or are we simply seeing the natural variation in a population of objects we're only beginning to discover? With only 3 confirmed interstellar visitors, it's hard to draw statistical conclusions. It's like trying to understand human diversity by looking at only 3 people. You might happen to select 3 individuals who are very different from each other, or you might select 3 who are remarkably similar. Without a larger sample size, it's impossible to know what's typical and what's exceptional. This brings us to an important point about the search for patterns and meaning in cosmic phenomena. Humans are pattern-seeking creatures. We see faces in clouds, warriors in constellations, and sometimes signals in noise. This tendency has served us well throughout our evolution, helping us identify threats and opportunities in our environment. But it can also lead us astray, causing us to see patterns where none exist, to find meaning in randomness. When we look at something like the fragmentation of 3I/ATLAS, we must be careful not to let our pattern-seeking instincts override our scientific judgment, and yet we must also be careful not to dismiss patterns simply because they are unexpected or inconvenient. The history of astronomy is full of discoveries that were initially dismissed because they didn't fit the prevailing paradigm. When pulsars were first discovered, their regular radio pulses were so artificial seeming that the discoverers initially called them LGMs, for little green men. They thought they might have found signals from an alien civilization. It turned out that pulsars were natural, the result of rapidly rotating neutron stars, but the initial instinct to consider an artificial explanation wasn't wrong. It was simply part of the scientific process, considering all possibilities before settling on the most likely explanation. The comparison between Oumuamua and 3I/ATLAS is particularly intriguing when we consider their different behaviours. Oumuamua remained intact throughout its passage through our solar system, maintaining its structural integrity despite passing closer to the Sun than 31/Atlas did. If Oumuamua was made of similar materials to 3I/ATLAS, why didn't it fragment? Was it simply a more robust object, or was it made of fundamentally different materials? Or could it be that they were both artificial but designed for different purposes, with different end-of-mission protocols? These questions become even more interesting when we consider the trajectories of these objects. Oumuamua came from the direction of the constellation Lyra, specifically from the vicinity of the star Vega. 3I/ATLAS came from the direction of Columba. These are very different regions of the sky, suggesting different origin points. If these objects are natural, this diversity makes sense. Different star systems would eject objects in different directions at different times. But if they're artificial, the different origins might suggest multiple civilizations, or perhaps a single civilization with probes stationed around multiple stars. The velocities of these objects also tell a story. Interstellar objects enter our solar system with a range of velocities relative to the Sun. These velocities depend on many factors, including the object's initial ejection velocity from its parent system and the gravitational influences it encountered during its journey. Oumuamua entered our solar system at about 26 kilometers per second, which is close to the average velocity of stars in our local neighborhood. This led some researchers to suggest that Oumuamua might not have been ejected from a star system at all, but might instead have formed in interstellar space, or been drifting for so long that its motion had equilibrated with the local stellar population. 3I/ATLAS had a similar approach velocity, also around 26 kilometers per second. This similarity is interesting but not necessarily meaningful. It could be coincidence, or it could reflect some underlying pattern in how interstellar objects are produced or distributed. With only 3 data points, we can't draw firm conclusions. But as we discover more interstellar visitors in the coming years, patterns may emerge that tell us something profound about the nature of these objects and their origins. The chemical composition of these objects provides another avenue for comparison. Borisov showed clear spectroscopic signatures of familiar molecules, confirming its cometary nature. Oumuamua was too faint for detailed spectroscopic analysis, leaving its composition largely a mystery. 3I/ATLAS showed some spectroscopic features consistent with carbon-rich compounds, but its fragmentation complicated the analysis. Each fragment might have had a slightly different composition, and we could only observe the combined light from all of them. This raises an interesting possibility. What if the fragmentation of 3I/ATLAS was not random but selective? What if different components of the object were designed to separate at different times or under different conditions? In our own spacecraft, we often use stage systems where different parts serve different functions and separate when their job is done. The Apollo missions used a multi-stage rocket to reach the Moon, with each stage separating after its fuel was exhausted. Could 3I/ATLAS have employed a similar principle, but on a more subtle level? If we allow ourselves to speculate further, we might imagine that each fragment of 3I/ATLAS had a specific destination or purpose. Some fragments might have been aimed at the inner planets, others at the asteroid belt, still others at the outer solar system. By fragmenting when and where it did, the object could have distributed its payload across a wide region of space. This would be an efficient way to explore or monitor multiple locations with a single probe. Of course, this is pure speculation. We have no evidence that the fragments of 3I/ATLAS were aimed at specific targets, or that they were anything other than random debris from a disintegrating comet. But the speculation itself is valuable, because it helps us think about what we should be looking for. If there are artificial interstellar probes visiting our solar system, how would we recognize them? What signatures would they leave? What behaviors would distinguish them from natural objects? One approach is to look for anomalies, things that don't fit our models or expectations. The acceleration of Oumuamua was one such anomaly. The fragmentation pattern of 3I/ATLAS might be another. But anomalies alone aren't enough. We need multiple lines of evidence, convergent observations that all point to the same conclusion. We need to be able to rule out natural explanations, or at least show that artificial explanations are more probable. This is where the scientific method becomes crucial. We form hypotheses, make predictions, and test them against observations. If 3I/ATLAS was artificial, we might predict that its fragments would show unusual compositional or isotopic ratios, different from what we see in solar system comets. We might predict that some fragments would display non-gravitational accelerations that can't be explained by outgassing. We might predict that the fragments would follow trajectories that seem optimized for observing or reaching specific targets. Unfortunately, the fragments of 3I/ATLAS quickly became too faint to track in detail. We lost sight of them as they dispersed, taking their secrets with them. This is one of the frustrating aspects of studying interstellar visitors. They appear briefly, often without warning, and then fade from view before we can fully study them. By the time we recognize them as interstellar and mobilize our observational resources, they're often already on their way out of the solar system. This is why some astronomers are calling for dedicated surveys and rapid response protocols for interstellar objects. If we could detect these visitors earlier, track them more carefully, and perhaps even send spacecraft to intercept them, we could learn so much more. There are already proposals for missions that would chase down future interstellar visitors using advanced propulsion systems to match their trajectories and study them up close. Such missions would be challenging and expensive, but the scientific payoff could be enormous. Imagine if we could have sent a probe to 3I/ATLAS before it fragmented. We could have analyzed its composition in detail, mapped its structure, perhaps even collected samples. We could have watched the fragmentation process up close, determining whether it was triggered by solar heating, tidal forces, or something else entirely. We could have followed individual fragments, tracking their trajectories and analyzing their properties. The data from such a mission could have definitively answered many of our questions about this mysterious object. But even without such direct exploration, we can learn from what we did observe. The fragmentation of 3I/ATLAS, whether natural or artificial, tells us something about the diversity of interstellar objects. Not all of them are like Borisov, stable and comet-like. Not all of them are like Oumuamua, enigmatic and intact. Some of them, like 3I/ATLAS, are fragile or perhaps designed to be temporary. This diversity itself is informative. It suggests that interstellar space contains a wide variety of objects with different origins, compositions and destinies. As we continue to monitor the skies, we will undoubtedly discover more interstellar visitors. Each one will add to our understanding, helping us build a more complete picture of what's out there in the vast spaces between the stars. Some will probably be clearly natural, obvious comets, or asteroids that just happen to come from other star systems. Others might be ambiguous, displaying properties that challenge our understanding and fuel debates about their nature. And perhaps, just perhaps, one will be unambiguously artificial, a clear signal that we are not alone in the universe. The search for artificial interstellar objects is part of the broader search for extraterrestrial intelligence, or ZTI. For decades, SETI researchers have been listening for radio signals from other civilizations, scanning the sky for transmissions that could only be produced by technology. So far, this search has found nothing definitive, only tantalizing hints and false alarms. But the search continues, driven by the profound implications of what we might find. The idea of searching for physical artifacts rather than signals is sometimes called SETA, the search for extraterrestrial artifacts. It's based on the recognition that physical objects might be easier to detect than electromagnetic signals, especially over long time scales. A radio signal lasts only as long as someone is transmitting it, but a physical artifact could persist for millions or billions of years. If advanced civilizations have been sending probes throughout the galaxy, for eons there could be numerous artifacts in our solar system waiting to be discovered. Some researchers have suggested that we should look for artificial objects in stable locations in our solar system, places where they could remain for long periods without being disturbed. The Lagrange points, where the gravitational forces of the Sun and planets balance, are one possibility. The asteroid belt is another. These regions could harbour ancient probes, dormant or active, observing our solar system and perhaps waiting for us to develop the technology to find them. The Moon has also been suggested as a place to look for alien artifacts. Its surface preserves impact craters for billions of years, and any artificial objects that landed there would remain relatively undisturbed. Some researchers have even analysed Apollo photographs looking for anomalies that might indicate artificial structures, though nothing convincing has been found. But the far side of the Moon, which we've explored much less thoroughly, could still hold surprises. The idea that our solar system might contain alien artifacts is not new. It's been a staple of science fiction for decades, from Arthur C. Clarke's 2001, A Space Odyssey, with its mysterious monoliths, to more recent works exploring the idea of ancient alien probes. But increasingly it's also being taken seriously by scientists. The discovery of interstellar objects like Oumuamua and 3I/ATLAS has shown that objects from other star systems do visit us. The question is whether any of them are artificial. As we reflect on the mystery of 3I/ATLAS and its strange fragmentation, we're reminded of how much we still don't know about our cosmic neighbourhood. Every new discovery seems to raise more questions than it answers. Every mystery we solve reveals new mysteries beneath it. It's like peeling an onion, layer after layer, never quite reaching the centre. But perhaps that's as it should be. Perhaps the joy is in the journey, not the destination. Perhaps the questions are more important than the answers. The fragmentation of 3I/ATLAS might have been completely natural, the result of well-understood physical processes acting on a fragile comet. Or it might have been something more, a signal or a probe or something we haven't even imagined. We may never know for certain, but the very fact that we can ask these questions, that we can detect and track objects from other star systems, that we can speculate about alien probes and interstellar messages, is remarkable. We are the universe trying to understand itself, cosmic matter that has become conscious and curious. As you drift deeper into sleep, consider the fragments of 3I/A TLAS continuing their journey through the darkness. Some are heading back to interstellar space, carrying with them whatever secrets they hold. Others might still be in our solar system, too small and dark for us to see, but there nonetheless. They're like cosmic seeds, scattered by a celestial wind, each one carrying the potential for discovery, for understanding, for connection with something beyond our small world. The fragments of 3I/ATLAS drift onward through the cosmic dark as we turn our thoughts to one of the most profound questions humanity has ever asked. It's a question that becomes even more compelling when we consider the possibility that objects like 3I/ATLAS might be more than they appear. The question is simple to ask, but impossible to answer with certainty. Are we alone? This question has haunted us since we first looked up at the stars and realized they were other suns, possibly warming other worlds, perhaps nurturing other minds, contemplating the same vast darkness, and wondering if somewhere, someone else was wondering too. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos when the conversation turned to the possibility of extraterrestrial life. Fermi, with characteristic directness, asked a question that has echoed through the decades. Where is everybody? If the universe is as vast and old as we know it to be, if stars and planets are as common as we've discovered them to be, if life arises readily under the right conditions as we suspect it might, then the galaxy should be teeming with civilizations. Some of these civilizations should be millions or billions of years older than ours, with technology far beyond our imagination. They should have colonized the galaxy by now, or at least filled it with their signals and probes. Yet when we look at the sky, we see no obvious signs of intelligence. We hear no cosmic chatter on our radio telescopes. We find no undeniable artifacts of alien technology. The universe appears to be empty of intelligence except for us. This is Fermi's paradox, though perhaps we should call it something gentler, something that captures not the harsh contradiction but the gentle mystery. Let's call it the Great Silence. The Great Silence is not really silent, of course. The universe is full of noise, full of signals. Pulsars broadcast their rhythmic pulses across the galaxy. Quasars roar with the energy of entire galaxies. Stars sing in frequencies we're only beginning to hear. But none of this cosmic symphony seems to carry the signature of intelligence, the intentional patterns that would indicate someone is trying to communicate. It's like being in a vast forest, hearing the wind in the trees, the calls of birds, the rustling of leaves, but no human voices, no sign that anyone else is there. The forest is alive, vibrant, beautiful, but you seem to be the only conscious observer, the only one capable of appreciating its beauty and wondering about its meaning. There are many proposed solutions to the Great Silence, each with its own implications for our place in the universe. Perhaps life is incredibly rare, requiring such a precise combination of conditions that Earth is one of the only places in the galaxy where it has arisen. Perhaps simple life is common, but complex life is rare, with most worlds hosting nothing more sophisticated than bacteria. Perhaps intelligence is rare, or perhaps technological civilization is rare. Each step from non-life to life, from simple to complex, from complex to intelligent, from intelligent to technological, might be a filter that few worlds pass through. We've passed through these filters, but perhaps we're among the lucky few. Or perhaps the filters lie ahead of us, not behind. Perhaps most civilizations destroy themselves soon after developing technology, victims of nuclear war, environmental collapse, or dangers we haven't yet imagined. This is a sobering thought as we grapple with our own existential challenges. Climate change, nuclear weapons, artificial intelligence, biotechnology. Each of these could potentially end our civilization or even our species. Perhaps the Great Silence is telling us that the universe is littered with the ruins of civilizations that didn't navigate these challenges successfully. Perhaps we're not alone, but we're surrounded by the dead. But there's another possibility. one that brings us back to 3I/ATLAS and its gentle fragmentation. Perhaps advanced civilizations are not silent but subtle. Perhaps they don't announce themselves with powerful radio broadcasts or massive engineering projects visible from across the galaxy. Perhaps they've learned to be quiet, to observe without being observed, to travel without leaving obvious traces. Perhaps the great silence is not a silence at all, but a whisper we haven't yet learned to hear. Think about how our own approach to exploration has evolved. Early human explorers were often loud and disruptive, claiming lands, extracting resources, imposing their will on the places they discovered. But modern scientific exploration, especially of sensitive environments, emphasizes minimal impact. When we study endangered species, we try not to disturb them. When we explore pristine wilderness areas, we follow the principle of leave no trace. When we send probes to potentially habitable worlds like Mars or Europa, we sterilize them carefully to avoid contamination. Perhaps advanced civilizations have taken this principle to its logical conclusion, exploring the universe in ways that don't disturb or contaminate the worlds they study. This could explain why objects like 3I/ATLAS, if they are indeed artificial, are so ambiguous. A civilization that wanted to study our solar system without alerting us to their presence would design probes that look natural, that behave in ways that can be explained by known physics, that leave room for doubt about their artificial nature. The fragmentation of 3I/ATLAS could have been engineered to look like a natural cometary breakup while actually serving some other purpose. It's the perfect camouflage, hiding in plain sight among the countless natural objects that populate our solar system. The idea that we might be under observation without knowing it is both unsettling and oddly comforting. Unsettling because it challenges our sense of privacy and autonomy. We like to think that we're the authors of our own story, not characters in someone else's observation log. But it's also comforting because it means we're not alone. If someone is watching us, it means intelligence has arisen elsewhere, has survived whatever challenges we're facing, has developed the technology to cross interstellar distances. It means the universe has produced consciousness more than once. That thought and awareness are not unique to Earth. The great silence might also be a consequence of the vast scales of space and time involved in interstellar communication and travel. Even at the speed of light, signals take years to travel between stars. A conversation with a civilization around Proxima Centauri, our nearest stellar neighbor, would involve a minimum 8-year delay between question and answer. For more distant stars, the delays would be decades, centuries, millennia. By the time a signal reaches its destination, the civilization that sent it might have changed beyond recognition, or ceased to exist entirely. Perhaps civilizations have learned that interstellar communication is impractical and have stopped trying. Physical travel between stars is even more challenging. Even with advanced technology, interstellar journeys would take enormous amounts of time and energy. A civilization might decide that the costs outweigh the benefits, that it's better to focus on their own star system rather than trying to explore or colonize others. Or they might send probes rather than themselves, automated explorers that can survive the long journeys and report back their findings. These probes might be designed to be as efficient as possible, using minimal energy, making minimal impact, like cosmic whispers rather than shouts. The timing of our search for extraterrestrial intelligence might also explain the Great Silence. We've only been capable of detecting radio signals from space for about a century. We've only been actively searching for such signals for a few decades. In cosmic terms, this is less than a blink of an eye. If civilizations typically use radio for only a brief period before moving on to other technologies, we might have missed their signals entirely. They could have been broadcasting for thousands of years, but if that period ended before we developed radio telescopes, we would never know. There's also the possibility that we're looking for the wrong things in the wrong places. We search for radio signals because that's a technology we understand. We look for Dyson spheres and other megastructures because we can imagine building them ourselves someday. But an advanced civilization might use technologies we can't even conceive of, might communicate in ways that are invisible to us, might modify their environment in ways we wouldn't recognize as artificial. We're like islanders looking for smoke signals while aircraft fly. Overhead, their contrails dismissed as unusual clouds. The discovery of interstellar objects like Oumuamua, Borisov, and 3/ATLAS adds a new dimension to our thinking about the Great Silence. If natural objects can travel between star systems, then so can artificial ones. If we're seeing natural interstellar visitors every few years with our current detection capabilities, how many artificial ones might we be missing? How many probes might have passed through our solar system over its 4.6 billion year history? Even if only a tiny fraction of interstellar objects are artificial, the cumulative number over geological time could be substantial. This brings us to an interesting calculation. If an advanced civilization sent out self-replicating probes that could build copies of themselves using materials from asteroids and comets, those probes could spread throughout the galaxy in just a few million years, even traveling at a small fraction of the speed of light. Each probe would arrive at a star system, make copies of itself, and send those copies onto other stars. It's an exponential process that could quickly explore vast volumes of space. If any civilization in our galaxy's history has done this, their probes should be everywhere by now, including our solar system. But we don't see them, or at least we don't recognize them. This could mean that no civilization has ever launched such probes, perhaps because of technical challenges we don't yet understand or ethical considerations about contaminating other star systems. Or it could mean that the probes are here but hidden, designed to observe without being observed. Or perhaps they're not hidden at all, but we don't recognize them because they're so different from what we expect. Perhaps some of the objects we classify as asteroids or comets are actually ancient probes, dormant or damaged, their true nature obscured by millions of years of cosmic weathering. The fragmentation of 3/ATLAS takes on new meaning in this context. If it was a probe, perhaps it was an old one, a relic from some ancient exploration program that finally succumbed to the accumulated damage of eons in space. Or perhaps it was functioning as designed, its fragmentation a planned event triggered by its entry into our solar system. The fragments could be spreading throughout our cosmic neighborhood, each one a separate sensor or beacon, collectively mapping our solar system in ways we can't detect. Consider how we might design an interstellar probe if we had the technology. We'd want it to be robust enough to survive the journey, but we'd also want it to be efficient, carrying no more mass than necessary. We might use materials that are common in space, like ice and carbon compounds, so the probe could refuel or repair itself using resources from comets and asteroids. We might design it to fragment upon arrival, spreading sensors across the target system to gather data from multiple locations simultaneously. We might make it look like a natural object to avoid alarming any inhabitants of the system. In other words, we might make something very much like 3/ATLAS. The Great Silence might not be a paradox at all, but a misunderstanding. We expect the universe to be loud with intelligence, but perhaps intelligence naturally tends toward quietness. On Earth, the most successful species are often those that avoid drawing attention to themselves. Predators hunt silently. Prey animals hide and camouflage themselves. Even among humans, the wise often speak softly while fools shout. Perhaps cosmic intelligence follows similar patterns, with advanced civilizations learning to explore and communicate subtly, rather than broadcasting their presence to the universe. This could be especially true if the galaxy contains multiple civilizations at different levels of development. A very advanced civilization might feel a responsibility to avoid interfering with younger civilizations, allowing them to develop naturally without outside influence. This is the zoo hypothesis we touched on earlier, the idea that Earth is essentially a nature preserve, protected from contact until we're ready. The occasional interstellar visitor like 3/ATLAS might be the equivalent of a research drone, carefully designed to observe without disturbing, to gather data without making contact. The Great Silence might also reflect the vast diversity of possible minds in the universe. We assume that alien intelligence would think somewhat like us, would have similar goals and motivations, would communicate in ways we could understand, but intelligence might take forms we can't imagine, with thought processes utterly unlike our own. They might perceive time differently, thinking so slowly that a single thought takes centuries, or so quickly that our entire civilization is just a brief flicker to them. They might exist in dimensions we can't perceive, or in states of matter we don't understand. The universe might be full of intelligence that we simply can't recognize as intelligence. As we contemplate these possibilities, the night deepens around us, and perhaps you're beginning to feel the gentle pull of sleep. But before we drift too far into dreams, let's consider what humanity has been broadcasting into the cosmic darkness, our own attempts to break the Great Silence. For we are not just listeners in this cosmic conversation. We've also been speakers, sending our own messages to the stars, hoping that somewhere, someone might be listening. Our first inadvertent messages to the cosmos began about a century ago with the invention of radio. Every radio and television broadcast leaks some energy into space, spreading outward at the speed of light like ripples on a cosmic pond. By now, our earliest broadcasts have travelled about 100 light-years, encompassing thousands of stars. Any civilization with sensitive enough receivers within that bubble could potentially detect our signals, could know that Earth hosts a technological species. They've heard our news broadcasts, our music, our stories. They've witnessed our wars and celebrations, our triumphs and tragedies, all encoded in electromagnetic waves spreading through the darkness. But these inadvertent signals are weak, fading quickly with distance. By the time they've travelled even a few light-years, they are almost indistinguishable from background noise. If we want to deliberately communicate with other civilizations, we need to send stronger, more focused signals, and we have. Several times over the past decades, we've aimed powerful radio transmitters at nearby stars and broadcast messages designed to be understood by alien minds. These messages have included mathematical concepts, descriptions of our biology and chemistry, even music and art. They're bottles thrown into the cosmic ocean, hoping to wash up on some distant shore. The most famous of our deliberate messages are probably the golden records aboard the Voyager 1 and 2 spacecraft. Launched in 1977, these probes have now left our solar system and entered interstellar space. Each carries a gold-plated copper disc containing sounds and images from Earth. Greetings in 55 languages, music from different cultures and eras, sounds of nature, images of our planet and its inhabitants. The records are designed to last for billions of years, longer than our sun will shine, long after Earth has changed beyond recognition, long after humanity has evolved into something else or ceased to exist. These records will drift through the galaxy, carrying a snapshot of what we were, what we valued, what we wanted to say to the universe. The golden records are moving slowly by cosmic standards, travelling at about 17 kilometers per second. At this rate, it will take them tens of thousands of years to reach even the nearest stars. But they're not really aimed at any particular destination. They're simply drifting through space, following trajectories that will eventually take them out of the galaxy entirely. The chances of them being found by another civilization are vanishingly small. Space is simply too vast, too empty. But the records were as much for us as for any hypothetical aliens. They forced us to think about how we would present ourselves to the cosmos, what we would want to say if we had the chance. Creating messages for unknown alien minds is a fascinating challenge. We can't assume they'll understand our languages or even our mathematics. We can't assume they'll perceive the same range of electromagnetic radiation that we do, or that they'll have the same senses. So we try to build from universals, from things that any technological civilization would presumably understand. Physics is the same throughout the universe. Mathematics, at least basic mathematics, should be universal. The hydrogen atom is the same everywhere. From these foundations, we try to build bridges of understanding to create messages that could be decoded by minds utterly unlike our own. But what if physical artifacts are better messengers than electromagnetic signals? What if instead of broadcasting messages, we should be sending probes, like the hypothetical probe that 3I/ATLAS might have been? Probes have advantages over signals. They can carry more information. They can be discovered long after they were sent. They can potentially interact with their discoverers, answering questions, providing additional information based on what's requested. A probe is a gift that keeps giving, while a signal is heard once and then is gone. We're already beginning to think about interstellar probes. Projects like Breakthrough Starshot propose sending tiny spacecraft to nearby stars using powerful lasers to accelerate them to a significant fraction of the speed of light. These probes would be simple, carrying little more than cameras and transmitters, but they could reach Proxima Centauri in just 20 years rather than the tens of thousands of years it would take with current technology. If we can imagine such probes, if we're already planning them, then surely older civilizations have already built and launched them. Perhaps some of them have already passed through our solar system. Perhaps 3I/ATLAS was one of them. The way 3I/ATLAS fragmented could itself be seen as a form of communication. Not a message in the conventional sense, but a demonstration, a proof of capability. If the fragmentation was controlled, if it was designed to happen in just that way at just that time, it would show a level of engineering sophistication that would be unmistakable to any observing civilization. It would be like a calling card, a way of saying, "We were here, we could do this, we're watching." The message wouldn't be in words or equations, but in the action itself, in the precise control of matter and energy across interstellar distances. This brings us to an interesting question about the nature of interstellar communication. We tend to think of communication as the transfer of specific information, facts, ideas, emotions. But perhaps at the interstellar scale, the mere fact of communication is more important than its content. Perhaps the message is simply, "You're not alone." Perhaps that's all we really need to know, all we really want to know. The specific details of an alien civilization, their biology, their history, their technology, might be interesting, but ultimately less important than the simple fact of their existence. As we listen to the cosmos, as we search for signals and artifacts, we're really searching for ourselves. We want to know if intelligence is a cosmic accident or a cosmic inevitability. We want to know if we're unique or part of a vast community of minds. We want to know if our struggles and achievements matter on a cosmic scale, or if we're just a brief flicker of consciousness in an otherwise unconscious universe. The Great Silence doesn't answer these questions, but it frames them, gives them urgency and poignancy. The possibility that 3I/ATLAS was artificial, however remote, reminds us that the universe might be trying to communicate with us in ways we don't yet recognize. Perhaps the Great Silence is not a silence at all, but a language we haven't learned to speak. Perhaps the cosmos is full of messages written in the trajectories of interstellar objects, the patterns of stellar variation, the distribution of dark matter, the structure of space-time itself. Perhaps we're surrounded by communication but lack the conceptual framework to recognize it as such. Consider how our understanding of the universe has changed over time. Ancient humans saw the stars as gods or spirits, interpreting their movements as divine messages. Medieval scholars saw the heavens as perfect crystalline spheres, a cosmic clockwork revealing the mind of God. Early modern scientists saw a mechanical universe governed by mathematical laws. Today we see a quantum universe, strange and probabilistic, full of dark matter and dark energy we don't understand. Each generation thinks it finally understands the cosmos, only to discover new mysteries that require new ways of thinking. Perhaps recognizing interstellar communication requires another such shift in perspective, a new way of seeing that we haven't yet developed. The search for extraterrestrial intelligence is ultimately a search for meaning. We want to know that consciousness is not an accident, that awareness is a fundamental feature of the universe rather than a random byproduct. We want to know that someone else has faced the challenges we face and survived them. We want to know that it's possible for intelligence to persist, to spread, to flourish among the stars. Every interstellar object that visits our solar system, whether natural or artificial, is a reminder that we're connected to the cosmos, that we're part of something larger than ourselves. As you drift towards sleep, perhaps you can feel that connection, that sense of being part of the vast cosmic web. The atoms in your body were forged in the hearts of dying stars, scattered through space in supernova explosions, gathered together by gravity to form our sun and earth, and eventually you. You're literally made of stardust, a collection of cosmic material that has temporarily assembled itself into a pattern capable of contemplating its own existence. In this sense, you are the universe looking at itself, a brief moment of cosmic self-awareness. The fragments of 3I/ATLAS continue their journey through the darkness, each one following its own path, carrying its own secrets. Perhaps they're nothing more than chunks of ice and rock, debris from a comet that couldn't withstand the sun's heat. Or perhaps they're something more, messages or messengers we don't yet know how to read. Either way, they're part of the grand cosmic story, the endless dance of matter and energy, information and entropy that has been playing out since the beginning of time. The great silence surrounds us, but it's not an empty silence. It's full of potential, full of questions, full of possibilities. Every moment the universe is speaking to us in languages we're only beginning to learn. The language of gravitational waves, the language of neutrinos, the language of dark matter. Perhaps one day we'll discover that intelligence has been speaking to us all along in these cosmic tongues, that the great silence was only our deafness to frequencies we couldn't yet hear. But for now we listen with the tools we have, we search with the knowledge we've accumulated, we wonder with the imagination we've evolved. We send our messages into the darkness, not knowing if anyone will ever receive them. We watch for visitors from other stars, not knowing if any of them carry messages for us. We exist in this moment of uncertainty, this pause between cosmic loneliness and cosmic community, not knowing which way the balance will tip. The beauty of unknowing is that it leaves room for hope, for wonder, for possibility. If we knew for certain that we were alone, the universe might seem colder, emptier, less meaningful. If we knew for certain that we were surrounded by advanced civilizations, we might feel small, primitive, overwhelmed. But in this state of unknowing, we can be both humble and proud, both seekers and pioneers, both students of the cosmos and its only known conscious observers. The story of 3I/ATLAS is ultimately a story about questions rather than answers. Was it natural or artificial? Was its fragmentation random or deliberate? Were its fragments messages or just debris? We don't know, and perhaps we never will. But the questions themselves are valuable. They push us to think beyond our assumptions, to imagine possibilities we hadn't considered, to look at familiar phenomena with fresh eyes. They remind us that the universe is far stranger and more wonderful than we can imagine, that there are more things in heaven and earth than are dreamt of in our philosophy. As sleep approaches, as your consciousness begins to fragment like 3I/ATLAS, breaking apart into dreams and unconscious processes, remember that you are part of this cosmic mystery. Your thoughts, your dreams, your very existence are part of the universe's attempt to understand itself. Every question you ask, every wonder you feel, every moment of awe at the vast darkness punctuated by islands of light, adds to the sum total of cosmic awareness. You're not separate from the universe, but an integral part of it, a way for the cosmos to know itself. The fragments of 3I/ATLAS will continue their journey long after you've fallen asleep, long after you've woken, long after all of us have returned to the stardust from which we came. They'll carry their secrets through the darkness, Whether those secrets are simple or profound, natural or artificial, they'll be joined by other interstellar visitors, a steady trickle of cosmic wanderers passing through our solar system, each one a messenger from the vast beyond, each one a reminder that we're part of something immeasurably larger than ourselves. Perhaps one day, maybe tomorrow, maybe in 1,000 years, we'll detect an interstellar visitor that is unambiguously artificial. Perhaps it will broadcast a signal as it approaches, or unfurl a solar sail, or change course in a way that no natural object could. Perhaps it will be covered in symbols or structures that could only be created by intelligence. When that day comes, if it comes, everything will change. We'll know that we're not alone, that intelligence is not unique to Earth, that consciousness is a cosmic phenomenon rather than a local accident. The great silence will be broken, replaced by the knowledge that others are out there, watching, waiting, wondering just as we are. But until that day, we have the questions, the mysteries, the possibilities. We have objects like 3I/ATLAS that might be natural or might be more. We have the great silence that might be empty or might be full of whispers we haven't learned to hear. We have our own messages going out into the darkness, our radio signals and space probes carrying news of our existence to anyone who might be listening. We have our telescopes and detectors, growing ever more sensitive, scanning the skies for visitors and signals. And we have our imagination, our capacity to wonder, to dream, to envision possibilities beyond our current understanding. The universe is vast and old and strange. It's full of phenomena we don't understand, from dark matter to dark energy, to the nature of consciousness itself. In this cosmic context, the possibility that 3I/ATLAS was an artificial probe seems less outlandish, less impossible. The universe has already surprised us so many times, revealed itself to be stranger than we imagined. Why not one more surprise? Why not the biggest surprise of all? As you finally drift off to sleep, carried away on currents of drowsiness like fragments of a cosmic visitor dispersing through space, remember that you're part of this grand mystery. Your dreams tonight might touch on cosmic themes, might explore possibilities your waking mind hasn't considered. In dreams, we're all explorers of the impossible, visitors to strange worlds, recipients of messages from beyond. In dreams, the great silence might speak. The fragments of 3I/ATLAS might reassemble. The cosmos might reveal its deepest secrets. Tomorrow you'll wake to the same world, the same sky, the same stars hidden by daylight. But perhaps you'll look at them differently, knowing that among those points of light there might be others looking back. Perhaps you'll remember 3I/ATLAS and its mysterious fragmentation, and wonder what other cosmic mysteries are unfolding right now, unseen and unknown. Perhaps you'll feel more connected to the cosmos, more aware of your place in the grand scheme of things, more appreciative of the profound mystery of existence itself. The universe continues its patient unfolding, its slow revelation of wonders. Stars are born and die. Planets form and evolve. Life emerges and develops consciousness. Civilizations rise and perhaps fall. Messengers travel between the stars, carrying their cargo of information or mystery. And through it all, the cosmos maintains its great silence, or perhaps its great whisper, waiting for someone to finally understand what it's been trying to say all along. Sleep now, cosmic traveler. Let your consciousness fragment and disperse like 3I/ATLAS, spreading through the landscape of dreams. Tomorrow the mystery will still be there, waiting to be explored, waiting to be wondered at. Tomorrow there might be new discoveries, new interstellar visitors, new pieces of the cosmic puzzle. But tonight, rest in the beauty of unknowing, in the peace of being part of something vast and mysterious and wonderful. Rest in the knowledge that, whether we're alone or accompanied, whether the universe is empty or full of intelligence, we're here, we're aware, We're part of the cosmic conversation, even if we're the only ones speaking. The fragments of 3I/ATLAS continue their eternal journey, and so do we all, passengers on a small world orbiting an ordinary star in an ordinary galaxy, but extraordinary in our capacity to wonder, to question, to dream of what might be out there in the vast and beautiful darkness. Perhaps that's enough. Perhaps that's everything. Perhaps that's the message the cosmos has been trying to tell us all along. That consciousness, wherever it arises, however briefly it flickers, is the universe's way of appreciating its own beauty, its own mystery, its own magnificent and terrible silence.